Hello everyone, my name is Jarius from Monash University. Today I'm going to introduce the paper, which is a collaboration with my supervisor, Dr. Chakrit, and Professor Ahmed, the impact of correlated metrics on the interpretation of defect models, published at TSE. And let's start. Ensuring high quality of software systems with limited time and resources is challenging. For example, to maintain millions lines of code and release a version every 4 weeks with only 100 of developers. To address this challenge, research has introduced the concept of defect models, which are classifiers that are constructed using historical software data to identify risky modules and explain factors that impact software quality. Defect models help developers prioritize their limited resources on the most risky modules. Defect models also help managers better understand factors that impact software quality to chart appropriate quality improvement plans. Prior studies investigate the impact of many factors on software quality, for example, code complexity, code smell, developer activity, ownership, and experience. However, prior study raised concerns that these software metrics in defect data are often correlated and may impact the interpretation of defect models. An example of correlated metrics is lines of code and complexity. Another is aggregated metrics that aggregate values at the method level to the file level. Furthermore, as much as 63% of defect studies in the top SE venues from 2000 to 2011 do not consider such impact of correlated metrics on the interpretation of defect models. Therefore, in this paper, we ask, do correlated metrics have an impact on the interpretation and prediction of defect models? To address, we analyze the interpretation and prediction of defect models with and without correlated metrics. We use 14 datasets from several corpora of systems to commonly used classification techniques, 9 variants of techniques for interpreting defect models. These figures show the percentage of study datasets for each rank difference between models with and without correlated metrics. The light blue bars represent the consistent rank of the metric between models with and without correlated metrics. We find that 16 to 100% of the top rank metrics do not appear as the top rank metrics after removing correlated metrics. This highlights the risk of not mitigating correlated metrics, especially for ANOVA type 1. Second finding, this figure shows the percentage of datasets where the top rank metric is consistent among techniques for interpreting defect models. The red cell on the left-hand side shows the percentage with correlated metrics, while the blue cells on the right-hand side show the percentage after removing correlated metrics. We find that removing correlated metrics improves the consistency of the top rank metrics among techniques for interpreting defect models by 15 to 46%. This highlights the benefits of removing correlated metrics on the interpretation of defect models. And next, for the third finding, this figure shows the distributions of the performance difference between models with correlated metrics and without correlated metrics. We find that removing correlated metrics impact the model performance by less than 5 percentage points along 3 study evaluation measures. Finally, for the take-home message, one must mitigate, for example, remove correlated metrics to derive sound model interpretation. If you have any more questions, feel free to contact me with this email. Thank you very much for listening.